Welcome everyone. In this video lecture, we will solve a GATE 25 EC question in which we have to determine the value of electron diffusivity. So the question is the electron mobility mu n in a non-degenerate germanium semiconductor at 300 Kelvin is 0.38 meter square volt per second. The electron diffusivity Dn at 300 Kelvin in centimeter square per second we have to find, which is rounded off to the nearest integer each. Fill in the blanks. Okay, so that value we have to find and consider the Boltzmann constant Kb 1.38 into 10 to the minus 23 joule per Kelvin and the electron charge 1.6 into 10 to the minus 19 coulomb. So in the question, electron mobility, okay, that is our mu n, is given at 300 Kelvin temperature, 0.38 meter per volt second. Okay, and we have to find out the value of electron diffusivity Dn at 300 Kelvin, okay, in centimeter square per second. Okay, so this we have to find out. Okay, and the other thing is given is our what, the Boltzmann constant, okay, Kb 1.38 into 10 to the minus 23 joule per Kelvin and electronic charge. So we have to find Dn. Okay, so how to solve this one, this problem? So first of all, better to start with the basic that is given in the question. The given thing that is given in the question, electron mobility mu n value is given 0.38 meter square volt per second. Okay, at temperature is given 300 Kelvin. Okay, then we have to find Dn. So we have to find Dn as per the question. We have to find Dn at particular temperature 300 Kelvin and the Boltzmann constant value, Boltzmann constant value is given 1.38 into 10 to the minus 23 joule per Kelvin, and electronic charge here it is written as E 1.6 into minus 19 coulomb. So these four things are given. I am highlighting once again. These four things are given, so we have to find the value of Dn. Okay. So now to solve this problem, a very important formula we can say, the relationship between the electron mobility and electron diffusivity. The relationship between the electron mobility and diffusivity is given by one very fundamental formula. We can write as D, or better to write Dn by mu n equals to Vt. Okay, the thermal voltage, electron diffusivity, mobility, and thermal voltage. Okay, Dn mu n Vt, and this Vt is nothing but simply Kt by Q. Okay, or in general we can write as KBT, anything you can write T by E. Okay, same thing, K, instead of K we are writing KBT E. Then what we can write, the electron diffusivity Dn can be written as mu n Kb into T by electronic charge E. Okay, this one is the formula, and this one is nothing but simply Vt in volt, this having volt. Okay, so now how to solve? So in the question it is given mu n value. So mu n value we can write as simply 0.38 meter square volt per second. Okay, and this one is our kb. Kb value is given 1.38 into 10 to the minus 23 joule per Kelvin into T temperature Okay, joule per Kelvin, Kelvin cancel, joule by an electronic charge 1.6 into 10 to the minus 19, and this one is some thermal voltage Vt. The whole thing, that thing is our what? This thing is our Vt. Okay, this Vt. Yes or no? Then this one is Vt. So now we have to solve this one. So what we observe, this volt and this volt will be cancelled out. Okay, so meter square by second, the unit for the dn, meter square by, okay, but we have to find it centimeter square by per second. So now again what we will write, if we solve this one we can write as dn 0.38 into 1.38 into 300 divided by 1.6 into 10 to the power minus 23, okay, plus 19. Okay, then if we solve this one, simple calculation is there. If we solve this one, it will nearly come 98.325 into 10 to the power minus 4, and it is in the meter square second, meter square second. But in the question it is clearly mentioned that we have to find the value of dn in terms of centimeter square per second. Okay, that in centimeter square per second we have to find. The unit should be like centimeter per second. So, but our thing is coming in terms of meter square. So once again, this can be written as 98.325 into 10 to the power minus 4 into 1 meter square. So 1 meter equals to 10 to the power minus 2 centimeter into 10 to the power minus 2. So it should be centimeter square, because 1 meter equals to, oh, sorry, better to write 10 to the power 2 now. 1 meter equals to 100 centimeter. Okay, 10 to the power plus 2, 10 to the power plus 2, okay, divided by, okay, 1 meter 100 centimeter, or 10 to the power square centimeter. So 1 meter square is 10 to the power 4 centimeter square. So it should be 10 to the power 4. So this should be cancel out. So dn value will be nearly 98.325 centimeter square per second. So this one is the final answer. We can say dn equals to 98 point, but we have to round it off, round it to the value. So it is nearly equals to 98 centimeter square centimeter square per second. So the answer will be option number B will be the correct answer. You can say option number B is the correct answer. Okay. So option number B is the correct answer for this question. So the answer is 98 centimeter square per second. So the thing is that we have to know the formula. The formula is d by mu n equals to Vt, or simply Kt by Q, or Kb by T, Kb to T by Q, or by E. Okay, so this one is the important formula that we have to remember. So this is all about this question. So thank you for watching this video. Thank you.